Hello and welcome to wireless communication lecture series. Now in previous lecture we have discussed about free space propagation model. Now we will see the example based upon that. Here in example it is given that if a transmitter produce 50 watt of power, so PT is given, transmitted power is given to us. Express the transmit power in dBm and dB watt. So what we need to do, we need to represent this power in dBm and dB watt. Furthermore, if 50 watt is applied to unity gain antenna, that means we have GT, the gain of antenna is given as unity, with a 900 megahertz carrier frequency. The frequency is given, we can calculate the wavelength. Find the receive power in dBm at free space distance of 100 meter. So the distance is given, the free space distance is given. So now let us see the solution. The transmitted power in watt is given 50 watt and the carrier frequency is given as 900 megahertz. Now first thing, we want to convert this watt into dBm. So what we will do, we will take a log. To calculate in a dBm, we will take a 10 log power in watt divided by 1 milliwatt. Why 1 milliwatt? Because we want to calculate in dBm. So now we will put the values 10 log 50 divided by 10 to the power minus 3 and the answer is 47 dBm. Now second thing is we need to calculate in dB watt. So simply we need to say 10 log PT in watt. You cannot, it is not necessary to write this 1 watt. So 10 log 50 is 17 dB watt. So the first half is over. Now let us calculate the second part, that is the receive power in dBm. Now to calculate receive power in dBm, we will use the Friis formula, that is PR equal to PT GT GR lambda square divided by 4 pi d whole square into L. We know that PT is given as 50 watt, GT and GR is 1, and to calculate the lambda we can use this formula. Lambda is equal to C by F. C is speed of light, 3 into 10 raised to 8 meter per second, and F is given as 900 megahertz. So if you will find the lambda, we will have lambda is 1 by 3 and D is given as here 100 meter and L is 1. So now we will get PR is equal to 3.5 into 10 to the power minus 3 milliwatt. Now if you want to convert this milliwatt into the dBm, take a log of it. So 10 log of this particular value, because it is already in milliwatt, we will directly write it. So ultimately we will have minus 24.5 dBm as a received power at this distance D, 100 meter. So this is we got as a closing reference distance power. Now we will calculate the received power at 10 kilometer distance. So PRD in dBm is 10 log PRD0 by 0.001 watt plus 20 log D0 by D. This is what we have discussed in previous lecture. So this is already we have find PR at 100 meter distance, and then 20 log this D0 is what 100 and this D is 10 kilometers, so it is a 10,000, and we have already find this in previous slide. It is minus 24.5 dBm, and if you will solve this you will have a minus 40 dBm. So ultimately the power as 10 kilometer distance is minus 64.5 dBm. So I hope this lecture is helpful to you. Thank you so much for watching this video. Don't forget to subscribe this channel.